lesson is all about the fundamental theorem of algebra, which is a lot like the last lesson that we went through. However, there's a few differences. So we've already talked about the degree. The degree of your polynomial tells you how many zeros you have, right? So if you have a degree of 5, then you're going to have exactly 5 solutions. And that's provided that every time you have one that's repeated twice, that counts as 2 solutions. If it's repeated 3 times, that counts as 3 solutions, so on and so forth. So if I'm looking at 1a, it asks how many solutions does this equation have. I'm just looking at the biggest degree, so this has 3 solutions. All right, zeros, that's the same thing, right? Zeros, roots, solutions, x-intercepts. How many zeros does this function have? 4. So we're going to do the same thing, but this time instead of finding all real zeros, we are finding all zeros. So the first thing you want to figure out is how many answers you should have in the end. So in the end, I should have 5 answers. Now remember, that can be a combination of real zeros and imaginary zeros. They might all be real zeros. They might, almost all be imaginary zeros. It just depends. So we're going to do all the factors of 8, which in this case are 1 and 8, and 2 and 4. And then the only thing between 2 and 4 is 3. That does not go into 8, right? And then I would divide that by all the factors of 1. But do I need to divide those by 1? No. So I have 8 options. And just so we can kind of help ourselves along, we're going to graph that so that we can see which one of these we might want to divide by. So if you look at this, remember, if it curves on the x-axis, that means that that's going to count for 2 of your zeros. And then this one's crossing through, so that counts for 1. And if you're not sure if it's crossing right there, because remember we had a problem in the last lesson where it looked like it was turning on the x-axis, but it wasn't. You can go to zoom and zoom in, and then just move your little guy over to where you want to zoom in and look. Press enter, and then you'll be able to see that it's going to curve right there on the -1. So I know that that's going to count twice. And then I have the one over to the right that goes through 2. And that's going to count once. So that's 3 of my 5 zeros. So what does that mean about the other 2 zeros? They are going to be what? Imaginary. Remember, real zeros actually cross the x-axis, whereas imaginary zeros, they do not. So if I know I have 5 total, this is 2, 3 zeros that are real, that means the other 2 have to be imaginary. And they always come in pairs, by the way. So if I have 1 imaginary zero, I will have 2 for sure. Okay? So I know that I can divide by -1 twice and 2 once, which is what I'm going to do. So I'm going to start with the 2. Now remember, you want to make sure that you're not missing any terms. And if you look up here, you're missing x to the 4th. So I need to make sure I put a 0 in that spot. So I have 1, 0, 1, -2, -12, -8. And then I'm going to go through the whole process. So I drop the 1. 2 times 1 is 2, plus 0 is 2, times 2 is 4, plus 1 is 5, times 2 is 10, plus -2 is positive 8. 8 times 2 is 16, plus a -12 is 4, times 2 is 8, which gives me my remainder of 0. So remember, if I started with x to the 5th, the first time that I divide cuts that down to x to the 4th, and I kind of like to keep track of that if I'm going to divide multiple times. Now I'm going to divide by the -1, and I'm going to end up doing this twice. So I'm going to drop down these numbers, the 1, 2, 5, 8, and 4. And I go through the whole process again. So I drop the 1. 1 times -1 is -1, plus 2 is 1, times -1 is -1, plus 5 is 4, times -1 is -4, plus 8 is 4, times -1 is -4, which gives me that remainder of 0. So if this was x to the 4th, I divided. Now I'm at x to the 3rd. And I know that I can use negative 1 twice, so I'm going to divide by it again. So drop down the 1, the 1, the 4, and the 4. So I drop the 1. 1 times negative 1 is negative 1. Plus 1 is 0. Times negative 1 is 0. Plus 4 is 4. Times negative 1 is negative 4, which gives me a remainder of 0. And if that was x to the 3rd, when I divided, now I'm at x to the 2nd. So I have x to the 2nd. And then the term with the x is 0, so I don't have that. And then plus 4. And I'm going to set that equal to 0. So here's the thing. If I already know that I'm going to have two imaginary answers, that means in the end, I end up square rooting somehow a negative, right? That's the only way for me to get an imaginary number. So if I have three terms here, then I know I'm not going to be able to factor it because I know that my zeros are imaginary. I'll have to do the quadratic formula. Since I'm missing the x term, then I can just solve for this x right off the bat. So I'm going to go ahead and subtract the 4. So I get x squared is equal to negative 4. And then I can go ahead and square root to get rid of that square. But I'm not going to forget that I get a positive and a negative answer when I do that. So square rooting the negative gives me an I, and square rooting 4 gives me 2. So I have two answers there. So I'm going to list these kind of like they do in your online homework if we're doing online homework. So we have x is equal to negative 1, and that has a multiplicity of 2. Now remember, if you're using the online platform, you don't put that in there, right? And then you have x equals 2. And then you have these two right here. So the x equals positive 2i and x equals negative 2i. And if you count how many answers that is 1, 2, 3, 4, 5. And then you know you have all of your zeros. All right, so I'm going to go ahead. I know that in the end I should have 5 answers, right? 5 answers in total. So I'm going to take all the factors of 4, which is just 1, 2, and 4. And then I would divide that by all the factors of 1, but since it's 1, I don't need to write that. So I have 6 options. I'm going to go ahead and graph that. All right, so when we graph, I know that negative 1 is going to count once, right? And if you zoom in on this, you'll see it does turn on the x-axis right there at positive 1, so that counts for 2. So this is 3 real zeros, which means the other 2 of my 5 have to be imaginary, right? So I'm going to go ahead and I'm going to divide by the negative 1, and then I'll do the 1 twice. So I am not missing any terms up here. So I have 1, negative 3, 5, negative 1, negative 6, and 4. So I drop that 1. 1 times negative 1 is negative 1, plus negative 3 is negative 4, times negative 1 is positive 4, plus 5 is 9, times negative 1 is negative 9, plus negative 1 is negative 10, times negative 1 is positive 10, plus a negative 6 gives me 4, times negative 1 is negative 4, which gives me the remainder of 0. So if I started with x to the 5th, this would then drop to x to the 4th, and then I'm going to do it again with 1, but I'm going to do 1 twice, remember. So I'll drop down these numbers, 1, negative 4, 9, negative 10, 4. And then drop the 1. 1 times 1 is 1, plus a negative 4 is negative 3, times 1 is negative 3, plus 9 is 6, times 1 is 6, plus a negative 10 is negative 4, times 1 is negative 4, which gives me a remainder of 0. But I know 1 counts twice, so I'm going to go ahead and divide again. And I'm going to keep track. This was x to the 4th, so this would be x to the 3rd. So I have 1, negative 3, 6, and negative 4. It's really important to make sure that you have the right numbers when you drop them too. So I drop the 1. 1 times 1 is 1, plus negative 3 is negative 2, times 1 is negative 2, plus 6 is 4, times 1 is 4, which gives me a remainder of 0. So this would be x to the second. So I have x to the second minus 2x plus 4. And I could look to see if I can factor that, but I should already know that I can't because I only have 3 real zeros and the other 2 have to be imaginary. So I'm going to have to use my quadratic formula because I don't just have x squared to solve for. So my a value is 1, b is negative 2, and c is 4. So I've got x is equal to the opposite of b, so it would be positive 2, plus or minus the square root of b squared, so that's negative 2 squared, make sure you have parentheses around that, minus 4 times a is 1, times c is 4, all over 2 times a. Then you want to get the number that's under that root, which in this case ends up being negative 12. And if you did not get a negative underneath there, then that should be a big hint that you did something wrong because we already know that we should be square rooting a negative because we have an I. So you're going to have to reduce that root. So you can either do the factor tree or think about a perfect square and a prime number that make 12. I'll do the factor tree since that's kind of what we've done. So I have 2 to the second power times 3, and then we'll square root both of those. So that gives me 2 square roots of 3. So I'm going to replace the square root of 12 with 2 square roots of 3, and then I also have an I, right, because I square rooted this negative. And that should go in between the number and the root. So that would be 2I square roots of 3 all over 2. And then I realized that all 3 of these terms will divide by 2. So I've got 2 divided by 2 on bottom gives me 1, plus or minus this 2 divided by 2 gives me 1, I square root of 3. So there's my other 2 zeros. So I have x equals negative 1, x equals 1 with a multiplicity of 2. And then you have x equals 1 plus I square roots of 3, and x equals 1 minus I square roots of 3. And that gives you 5 answers. Now, if I had said find all real solutions, that would only be these 2, right? This would not be included in my answer. So always pay attention to the instructions. All right, so the complex conjugate theorem tells you that if you've got a polynomial that has real coefficients and a plus bi is one of your zeros, then so is a minus bi. It's kind of the same thing that we did with the roots, right? Like if 2 plus the square root of 5 is 1, then 2 minus the square root of 5 is 1. So it's exactly the same. You just, these always come in pairs. So I've got 2 as a 0, and 3 plus I is a 0. So that means that the other one would be 3 minus I. So in the end, I have 3 zeros, which means the degree of my polynomial in the end should be a 3, right? Because I have 3 solutions. So I'm just going to work backwards. If 2 was my 0, then that means the factor would be x minus 2. If 3 plus I is a 0, then x minus 3 minus I would be a 0. And if 3 minus I is a 0, then x minus 3 plus I would be my factor. And just like with the roots, we want to multiply the ones with the i's first because that should eliminate any I that we have. So I've got x times x is x squared. X times negative 3 is negative 3x. And x times I is xi. Then we've got our negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And negative 3 times I is negative 3I. And then we do the negative I times x is negative xi. Negative I times negative 3 is positive 3I. Oops, negative 3 times negative 3 is, oh wait, I'm on I. That's right, okay. And then negative I times positive I is negative I squared. And if you will recall, we never leave an I squared. It always changes. I squared is the same thing as a negative 1. So anytime I have an I squared, I'm going to change it to a negative 1. And then I'm going to have this negative times a negative 1 gives me a positive 1. So back here at the back, I really have a plus 1. So make sure you change that. So essentially, if I had like negative 8I squared, that changes to negative 1, right? And that changes to a positive 8. It's literally just going to change this to the opposite. So it would be a positive 8. So if I had negative 5I squared, that changes this to a positive 5. Okay? Just kind of like a trick for you at the back. So I'm going to leave my x minus 2 in the front. I'm going to go ahead and put together my like terms. So I always start with the I things because they should all cancel. So I have xi and negative xi. Negative 3i, positive 3i. That should all cancel. So I have x squared, negative 3x, and negative 3x make negative 6x. And then you have 9, and then the plus 1 at the back, which makes plus 10. So if you have an I left over at this point, then you have done something wrong because they should all cancel out. So then I'm going to go ahead and multiply these together. X times x squared is x to the third. X times negative 6x is negative 6x to the second. And x times 10 is 10x. Then we'll do the negative 2 times x squared is negative 2x squared. Negative 2 times negative 6x is positive 12x. And negative 2 times 10 is negative 20. And now we're ready to just combine like terms, so put your function notation in front. I have x cubed. Then we have negative 6x squared, negative 2x squared, which make negative 8x squared. 10x and 12x, that makes 22x. And then you have the minus 20. And we said that in the end we would have a degree of 3, right? So we have negative 1 is one of our zeros, and 4i, and so the other one would be negative 4i. So I've got x plus 1, x minus 4i, and x plus 4i. So in the end, since I have 3 answers, I should have a degree of 3 at the end of this. So I'm going to go ahead and do the ones with the i's first. So x times x is x squared. X times 4i is 4xi. Negative 4i times x is negative 4xi. And negative 4i times positive 4i is negative 16i squared. And we talked about this a while ago, right? This changes to a negative 1 times the negative 16, so that's actually going to make this a plus 16 at the back. So these two middle terms are going to cancel out. I've got my x plus 1 up the front, and this would be x squared, and then I'm going to have that plus 16 at the back. All of the i's are gone, and then I just multiply. So x times x squared is x to the third. X times 16 is 16x. 1 times x squared is x squared, and 1 times 16 is 16. And I don't have any like terms, but I still have to put this in order. So I have f of x is equal to x to the third, then my x squared, then my 16x, and then my 16. So on number 6, I've actually put in an I and a root. So if 2I is one of my zeros, then so is negative 2I. And 4 minus the square root of 6, then so is 4 plus the square root of 6. So in the end, the degree of my polynomial should be what? 5. 1, 2, 3, 4, 5. All right? So I've got x minus 2. And then for the 2i, I have x minus 2i. For the negative 2i, I've got x plus 2i. For the 4 minus the square root of 6, I have x minus 4 plus the square root of 6. And then for the 4 plus the square root of 6, I have x minus 4 minus the square root of 6. All right, so I know that when I multiply the parentheses that have the i's together, that gets rid of the i's, right? And when I multiply these two together, that gets rid of the roots. So we're going to do these two, then we'll do these two, then we'll combine some more, but we're going to start with those. So let's start with the I ones. We have x times x, which gives me the x squared. X times 2i is 2xi. Negative 2i times x is negative 2xi. And negative 2i times positive 2i is negative 4i squared, which is just going to make this positive 4, right? Now, if you have to go through the whole thing, that's fine. To make sense to yourself, that's not a problem. All right, these two will cancel in the middle. So I've got my x minus 2 up front, and then next I would have the x squared plus 4. So I've eliminated the i's. Now I'm going to go through and multiply these two here at the back. So x times x is x squared. X times the negative 4 is negative 4x. And x times negative square root of 6 is negative x square roots of 6. Then we'll do the negative 4 times x is negative 4x. Negative 4 times negative 4 is positive 16. And negative 4 times the negative square root of 6 is positive 4 square roots of 6. Then the square root of 6 times x is x square roots of 6. Square root of 6 times negative 4 is negative 4 square roots of 6. And the square root of 6 times a negative square root of 6 is negative 6. So I know anything with a root should cancel, right? Negative x squared root of 6, positive x squared root of 6 cancels. 4 square roots of 6, negative 4 square roots of 6 cancels. So behind my other two parentheses, I've got x squared, negative 4x, and negative 4x make negative 8x. And then 16 and negative 6 make 10. So now I have eliminated all of the problems, right? Now I'm just going to go ahead and multiply the first two together. So x times x squared is x to the third. X times 4 is 4x. Negative 2 times x squared is negative 2x squared. And negative 2 times 4 is negative 8. I don't have any like terms here, right? So I'm just going to go ahead and put them in order. So I have x to the third minus 2x squared plus 4x minus 8. And I'm going to multiply that times the parenthesis at the back. So we're finally on our last little stretch. All right, so I'm going to take all of these in the first one times all of these in the second one. So x to the third times x to the second is x to the fifth. X to the third times negative 8x is negative 8x to the fourth. X to the third times 10 is 10x to the third. Then I do the negative 2x squared times x squared is negative 2x to the fourth. Negative 2x squared times negative 8x is a positive 16x to the third. And negative 2x squared times 10 is negative 20x squared. Then we have 4x times x squared is 4x to the third. 4x times negative 8x is negative 32x to the second. And 4x times 10 is 40x. And then finally the 8. So negative 8 times x squared is negative 8x squared. Negative 8 times negative 8x is a positive 64x. And negative 8 times 10 is negative 80. So now I'm ready just to combine like terms and put it in order. So f of x is equal to, I have x to the fifth. That's the only one of those I have. I have a negative 8x to the fourth and a negative 2x to the fourth. That gives me negative 10x to the fourth. 10x to the third and 16x to the third give me 26. And then I have one more, add 4 to that, that gives me 30x to the third. Then we have negative 20x squared and negative 32x squared, which gives me negative 52x squared, minus another 8 would give me negative 60x squared. Then I have positive 40x and positive 64x, which would give me a positive 104x. And then last but not least, the minus 80. And we do have our degree of 5 because we started with 5 zeros. All right, so let's talk about like our number of positive real zeros and like our number of negative real zeros. So we have a rule of signs, Descartes' rule of signs, where if we have a polynomial with our real coefficients, the number of positive real zeros of f is equal to the number of changes in sign of the coefficients of our original function, or is less that by an even number. We'll talk about that in a minute. And the number of negative real zeros is equal to the number of changes in sign of the coefficients of f of negative x, or is less that by an even number. So the smallest even number is 2, right? So when it says less that by an even number, you would take away 2 from each possibility. So first, let's talk about positives because that's the easiest one. You're talking about sign changes. So like my first term is positive and my second term is negative. So that's one sign change, right? Then I go from a negative to a positive. That's another sign change. Then I go from a positive to a negative. That's another sign change. Then I go from a negative to a negative to a negative to a negative. So I only changed signs 3 times. So my positive 0 choices are 3, because there's 3 of them, or I'm going to subtract 2 until I get all the way to 0. So 3, or if I take away 2 from that, that would be 1. But I can't take 2 away from 1, right? So therefore, I either have 3 positive real zeros or I have 1 positive real zero. Okay? For the negatives, you have to do a little bit of work. So what you're going to do is you're going to go through and replace all of the x's with negative x's. So I've got negative x to the 6th minus 2 times negative x to the 5th plus 3 times negative x to the 4th minus 10 times negative x to the 3rd minus 6 times negative x to the 2nd minus 8 times negative x minus 8. And then you have to go through here and simplify these. So if I take a negative number and I raise that to an even power, every single time it comes out to be a positive. So that would be the same thing as taking x to the 6th. If I take a negative number and I raise that to an odd power, it's going to come out to be a negative number. And when I take that negative number times another negative number, that makes a positive number. If I take this negative and I raise it to an even power, it's going to come out to be positive times this positive would give me a positive number. A negative number raised to an odd power comes out to be negative. So this negative times a negative 10 would give me a positive. A negative number raised to an even power comes out to be positive times a negative would give me a negative. A negative x times a negative 8 gives me positive 8x. And then I have minus 8. All right, so what you're going to do is check your sign changes. So you've got positive, 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 negative. There's one sign change, and then negative to positive. There's another, and then positive to a negative. There's another. So for your negative zeros, you're either going to have 3 or take 2 away, that would be 1. So if this was like 4, it would be 4 or 2 or 0. Okay? Now, we're going to make ourselves a little table. So we've got positive real zeros. I'm going to put RZ for real zeros. Negative real zeros. Imaginary zeros, because we can have those, right? And then your total number of zeros. So let's just start by saying, okay, one of our possibilities for positives is a 3, right? So what is, how many zeros do I have in total for this equation? 6, right? 6 is the most I'm going to have. So I already know that my total zeros is 6. So if I have 3 positives, then I could possibly pair that with 3 negatives, right? That makes a total of 6 zeros. So how many imaginary zeros would you have in that case? None, because you've already used up your 6, right? Or I could have 3 positive zeros and 1 negative 0. That makes 4 zeros. So how many imaginary zeros would you have? 2, and that adds up to make 6. Okay, or I might have 1 positive 0, and I could pair that with 3 negative zeros. That makes 4 real ones, which means how many imaginary would you have? 2 for a total of 6. Or I could have 1 positive 0 paired with 1 negative 0. That's 2 real ones, which leaves how many imaginary? 4 of them for a total of 6. These are your possibilities. So it's kind of like this. It's almost like distributing. I could have 3 positives with 3 negatives or 1 negative, right? I could have 1 positive with 3 negatives or 1 negative. So you always want to focus on that. However many are left over after that out of your total is what goes for the imaginary section. Okay?